Assalamualaikum. Today we are going to present about our project CAD-CAM BMFR 3523. So the product we chose for this project is washing machine impeller. The group member consists of Muhamad, Afif bin Zuhairi, Fildzah, Yuhanis, Binti, Ahmad, Kamal, Hidayah, Binti, Muhamad, Piah, and Muhammad, Aiman, Mustaqim bin Arif, Hazmi. The objective for this project is the first one is to apply the basic principle of CAD in designing washing machine impeller by creating 3D models and generate detailed drafting of mechanical part using CATIA part design module. Next is to run simulation on machining operation and produce part programming for operations involved in producing impeller washer. Next, this is the Gantt chart, shows our progress of the project activity. Next, my friends will explain more about the design and also the simulation of our project.
Greetings to my lecturer. Now, I will explain about the design of our product. First, we pad the sketching of 20mm and the diameter of 20mm too. Then, we make a shell with inside thickness of 3mm. After that, we make the pad from bottom of the first pad to make the base with dimension of 120mm in diameter and 5mm of height. Next, to create a multi-section part, we take the upper part of the base to sketch the bottom part of multi-section. Then, for the upper part of multi-section, we have to make a plane as shown in the video. To make a multi-section layer, we drag the line from upper to bottom of the sketching. Next is circular pattern and pocket to make a hole at center with the shown diameter. Next, to make a slot, we have to sketch the arc as shown in the video. Then, we create a plane at the end point of the arc to sketch a circle with the shown dimension to make a slot. After that, same process as circular pattern as before. We make the copy of circular pattern of the slot. Lastly, we make an edge fillet of the edge of upper part of the base. This is the drafting part of our product. As can see on the video, we have top, front, side, isometric, sectional view of the product. The detailed view also shown in the video for the hole at the center of the impeller. All dimensions in millimeter are included to ease the designer of the product to design.
Following the completion of the product design stage, the simulation operation in the generation of NC code programming is required. The first process is to execute a facing operation to level the stock surface, which needs 6 process operation simulation comparable to 6 design features to develop NC code programming for this product. After the process operation facing machine simulation has been conducted at beginning of the simulation to achieve a level top surface, the following operation simulation, roughing machining, will be implemented. After that, a roughing machining operation is performed to create the desired product shape. The next simulation procedure is isoparametric machining operation, which build a curved surface between the base and the product surface. Following the isoparametric machining operation, a multi-axis curve machining simulation operation has been used to build a slot drain between the blade partition. Finally, there are tool holes in the center of the product. The first of which applies operation contouring machining simulation to create a biggest hole, and the second of which applies operation pocketing machining simulation to make a smaller hole.
Now we will go to the next topic of the project. My name is Fildzah Yuhanis and I will explain the discussion part and conclusion. First is the impeller design. So this figure shows the screenshot of completed impeller modeling in CATIA V5, and these are some specifications of the washing machine impeller that are used in the drawing. Next is the commands used in drawing. First, we have shell features. The hole outer diameter is 14mm and the hole inlet diameter is 10mm. Next, we have multi-section. The blade profile is the most important parts of impeller, should be designed with a careful estimation. The blade may look very simple, but lots of estimation should be done to design the blade profile. Thirdly is circular pattern. This command is used to generate another 6 blades with the same measurement uniformly around an axis. The height of the plate is 20mm with the outer radius of 42.4mm and inner radius of 37.5mm. Next is the pocket. The pocket command is to make a hole in the base part of washing machine impeller so that the shaft will make its space into the hole to aid the impeller to rotate. And lastly, slot. The thickness of the slot is 2mm. The slot located in between the blades that function as low profile cone or disc that spins or rotates to rub close against each other to get them clean. Next is impeller simulation. We have generated 6 machining processes to produce washing machine impeller. We are using milling tool throughout the process. And basically, the first process is facing machining. This process is to provide a true, flat surface, square, with the axis of the workpiece. Secondly, roughing machining. This phase constitutes the main material removal phase where the initial bulk material is removed up to a specific thickness. Thirdly is isoparametric machining. This process is the operation of strips of faces and machined along their isoparametrics. Next is multi-axis curve machining. This phase is to defining the radial condition of impeller. The fifth step is the contouring machining. Contouring is to creating a fine finish on an irregular or uneven surface. And last but not least, pocketing machining. This process uses an end mill type cutting tool and machine away large amount of material to finishing the part. The impeller can be done in estimated time of 2 hours 11 minutes with 70 rpm spindle speed and 100mm per minute feed rate for third stage of machining, the washing machine impeller. So the last part of this discussion is the ideas to improve the work. The blade is prone to cracks and deformation during processing because the space between subsequent blades is limited and the curve of the blade surface changes considerably. As a result, to successfully avoid overcutting and interference difficulties when the tool operates between neighboring blades and in the runner, the swing range of the tool axis must be properly controlled to provide smooth surface grain. To begin, it should be processed in the order listed above from the center to the impeller's outside edge with a reasonable roughing allowance. The impeller groove should then be roughed out with a conical ball end milling cutter with a greater diameter. The finishing hub is achieved by utilizing a smaller diameter ball end milling cutter, which not only uniformizes the surface of the hub but also assures improved machining precision. The milling sequence is as follows. The milling cutter grows from the middle to the outer edge, leaving enough room for the finishing blade. So we move on to the last part of this video presentation, which is conclusion. In conclusion, we managed to understand the basic principle of drawing parts and simulation in CATIA V5. The particular stage is the design stage of washing machine impeller. The impeller parts such as impeller blade and the pocket shaft are designed and viewed using 2D and 3D model. All those parts are designed carefully based on the detailed research as discussed in the previous section of this report. Another objective of this study is to ensure that students acknowledge the usage of every tool and command in drawing and simulation using CATIA V5. And that's all from us. Thank you. Stay safe and healthy.